Hello, welcome to the homework helper on how to construct a branch diagram. You might ask why you would want to construct a branch diagram. These can be useful if you want to find the phenotypic ratio or the genotypic ratio from a particular genetic cross. Our example will be for 2 genes, but you can extend this to as many genes as you want as long as those genes assort independently. So let's look at this cross. We're going to look at big A, big B, little b, crossed to big A, little b, little b. The first step is to do a one locus Punnett square for each of these 2 genes. I'll start with the A locus, and I'm crossing big A to big A little a. So half of my gametes are big A and half little a from each of the parents. After I have the gametes across the top and down the left-hand row, I can fill out the progeny genotypes by bringing down and across the gametes for each row and column. The progeny, 1/4 big A, 1/2 or 2/4 big A, and 1/4 little a. Now let's do the B locus. My cross here is big B crossed to little b. Half of my gametes from this first parent are big B and half are little b. All of the gametes from the second parent are little b. So half of my progeny are big B, and the other half are little b. Now let's put this into a branch diagram. It doesn't matter which gene I do first. I just have to make sure all of them get done at the end of the day. I'll start with the A locus. And here I'm worried about a phenotypic ratio. 3/4 of the phenotypes at the A locus will show the dominant type. So 3/4 are going to be big A something, and 1/4 is little a. I want to write that as part of my branch. 3/4 big A. And then I'll come down a bit, 1/4 little a. After I write the results for one locus down, I write the results for the second. Here, half of my progeny are big B, and half are little b. From each of the places for the first gene, I branch and write down the results of the second gene. So 1/2 big B, 1/2 little b. And I'll do the same thing and write this same thing down on the other part of my branch diagram. Now, if I had more genes, I would branch at this point all the way down to do the next gene. But here, since we're done, we just get to find out the frequency of each of these endpoints. To do that, I multiply the frequency at each point in the branch. So 3/4 times 1/4 is 3/8. 3/4 times 1/2, is 3/8. 3/4 times 1/2 is 3/8. 1/4 times 1/2 is 1/8. And 1/4 times 1/2 is 1/8. And then the genotype class that's going to be here is just what I had before, big A something, big B, little b. This is big A something, 2 little b's. Little a, big B, little b. Little a, little b, little b. So 3/8 of my progeny show the dominant phenotype for both of those loci. 3/8 are dominant for the A gene and recessive for the B locus. 1/8 are going to show the recessive trait at the A locus and the dominant at the B locus. And 1/8 will show, here we go, the recessive characteristics at both loci. I hope that has been helpful. Have a great evening.